Hey there, my name is Mauro Chojrin. I am a software craftsperson at Codurance, and today I'm going to show you a solution to a programming kata developed using PHP. The kata that I will be solving today is called Unusual Spending Kata. So let's quickly run through the text of the instructions. So here it says you work at a credit card company, and as a value add, they want to start providing alerts to users when their spending in any particular category is higher than usual. Payment is a simple value object with a price, description, and category. A category is an enumerable type or a collection of things like entertainment, restaurants, and golf. For a given user ID, fetch the payments for the current month and the previous month. Compare the total amount paid for each month grouped by category. Filter down to the categories for which the user spent at least 50% more this month than last month. And finally, compose an email message to the user that lists the categories for which spending was unusually high, with a subject like unusual spending of, in this case, $1,076 detected, and this body, and this is showing us a format of the email that should be sent. Okay, so for this particular video, I already have the code in place, so I'm going to be showing it to you and making sure we touch the most important points of the way that I solve this. If you want to follow along or take a look for yourself, this is the repository where you can get the code. It's mchojrin Codurance /unusual spending. So let's go into the IDE, shall we? So my starting point for this kata is the one that we have at Codurance Kickstart. You can check it out right here. And what it basically does, as was shown in the related video, is we have a very simple test class that is designed to be using PHP unit, and it tests this A class. So it's only meant for you to be able to assess that you have everything installed properly. So let's just run this test and see that it's working. And it says, okay, so the test finished, everything is all right. So this was my starting point. So now for the real starting point of the solution, let's go to Git history and see what we have right here. Let's check out this revision. Okay, so now that what we have here is one test class and one source code to be tested. So let's start with showing the trigger unusual spending email should, which is the test class. And as you can see, there's not really that much to it. As a matter of fact, if we look at the source code, it also doesn't have very much. And so the idea here is to take an outside-in approach, and that's why I started with what is going to be the first acceptance test. Here is I'm going to try to mimic everything in the instructions, and then make sure, well, the program does what it's supposed to. If we run this test, let's do it. It will run, but of course no tests were found in class because, well, there is none. So let's move forward a little bit to see some actual code. So let me go back to history. And so here we have, let's check this out. Okay, so now as you can see here, there are many new things, and I should probably have made a few commits on the way. Sorry about that, but I think it's still shows you a very good starting point. So now let's quickly examine what we have here, which is the acceptance test. So first of all, you can see here that I'm using Mockery. Mockery is a library to create test doubles, mocks and stuff, which is a little bit more comfortable and more powerful to use than the one that comes built in with PHP unit. So basically what I'm going to be doing here is assessing that the system is sending emails the way they should be sent. So at this moment, I realized I will be needing a few collaborators, namely a payment repository to keep track of the payments being made, a clock to keep track of the passing of time without relying explicitly on the system's clock, because that would make writing the tests more difficult. From the kata instructions, I get the notion that I'll be needing a value object to model payments. And while I could have used simple primitive types for the price and description and category, I prefer to go a little further and build small classes to prevent weird situations. So let's take a look at those. So here we can see that I have the, well, let's start with the clock. It's very simple. It doesn't really do many things. So it's the payment and payment description. So they are basically just wrappers around the primitive types. Okay, so let's go again and examine the actual test. All right, so I start setting up the scenario. I would usually start the other way around, like starting with the assertion. So let's go right there to the assertion. So in this case, what I want to assess is that the email has been sent. So I don't yet have a proper email sender class or anything like that. And besides, since I need to make an assertion about the execution of a method, the best way to go about that would be to create a test double, probably a spy. But at this point in time, I was using a mock. So this is what I'm saying exactly. It should receive the send, or what this means is the send method should be called once. And okay, so those are my expectations, and then I will act, make the I will trigger the email for the user ID number 1. And so now all of this is just setting up the stage. So let's see what I'm doing here is create the payment repository and the user ID. And here I am simply putting together some payments to, to have something to report on. One interesting aspect that I wanted to show you is that I am using a rather new feature of PHP, which is the enumerations. So that's basically to match the instructions of the kata. So I have a category which is an enumeration of either golf, entertainment, or restaurants, and I'll be using this throughout the code. As you can see here. Okay, so this is how I create new payments, and I will be adding these payments to the repository. So of course, in order for this to work, this add payment method needs to be not only defined, but also coded in a way that will perform some sort of action, which is something we are going to be seeing really soon. Actually, I can show you right now. It is definitely not doing many things, but I had to put this assist in order for the test to run. And okay, so this is, of course, I have made a few design decisions while creating this test, but that is also some of the idea of the outside-in approach. So basically what we have here is a test that I can run and it fails. Okay, so why is it failing? Because it fails to fulfill the expectations of the method being called. So basically what this means is that the test is failing for the right reasons, for the reasons I expect it to fail. This means the test is not failing because it's poorly written or it has like some syntax error or something like that. No, it's failing because the functionality isn't yet implemented, which is exactly what I expected. Okay, so now let's move a little forward in time. So we have this first failing test. Okay, so let's jump to this revision. where we have what is called a fake implementation. So let's see what this means. So what we have, this is the main difference, is that I am actually calling the send method. So if I run the test again, which should not have been changed. Okay, so I did make a few small changes here. As I mentioned earlier, I was going to use a spy, and this is what I'm doing now. But the essence of the test remains the exact same thing. So let's just run it. And okay, so we have, okay, one test, one acceptance. What this means is the test is now passing. But of course, as we can see in the functionality, it's not really very useful. But then again, this is a very classic way of working when you're using TDD, which is try to approach the solution in a very small or a very slow-paced way, right? So let's see how this story continues. So I'm going to jump ahead a couple of revisions here, and what we can see here is that I have refactored the test code to make it a little more readable. So let's see. So yeah, so what I have here is one method that will create the expected subject, and another that will create the expected value. So I'm not only just testing that the method is being called, but also what are the parameters that are sent to the method. So in a way, this is a more detailed test than the previous one that we had. And of course, this is much more in line with the verification of the correct behavior. So here we have this function that will create the scenario for me. Okay, so now moving forward to this revision, we have again a fake implementation, a more nuanced one, but still fake implementation that will make the test pass. Let's verify that. And okay, so now we have the test passing. So again, this is always the same cycle. We start with a failing test, then we create a fake implementation that will make the test pass, and that way we are approaching the right solution. So now in this revision, I'm going to do something a little more interesting, which is to set the stage for creating some parameterized tests. And the idea of using parameterized tests is that they are like harder to trick, or they are more realistic. So let's see the differences between this particular revision and the next one, which is something I will do along several revisions. It will be setting the stage for some parameterized tests. So let's see the difference. So here, as you can see, I am changing. No, this is not the one that I wanted to show you. This is the one. So this is the most important part. Is I am changing the definition of the function build expected value from a simple hard-coded implementation to something that can be parameterized. So I will be creating an expected value that will reflect the expectations of every parameterized test, or every set of parameters that I will use for constructing the tests. And okay, all right, and so I will have probably here something like another fake implementation that will maybe pass some of my tests. Now all of this will be completed by this revision. So let's check the differences. Let's see what happened at the test. And okay, so now you can see that first of all, I am using a data provider to be able to parameterize this test. So if you see, this is the original implementation, the current one, which is a simple test, and now I am sending some parameters to be able to use the same code with different data sets in order to make different assertions. And that's how the parameterized tests help you in putting together a more realistic implementation, or maybe to make sure that the code works for many cases and not just particular ones like the fake or hard code implementations. And so now I am using this build scenario function that I changed earlier to send these parameters and build an appropriate base scenario. And this means putting in some payments according to the parameters that are received. And okay, so then again, I am using some of these parameters to build the expected results, the subject and the body of the email being sent. Okay, here what we see is the actual data provider, which is a simple function that will return these numbers. Each element of this array corresponds to a parameter of the function. So, for instance, this 20.7 would be the restaurant spend, and the second would be the entertainment spend, and the second month multiplier. All right. So that's the idea. I am forcing the extra expenditure on, or the unusual spending in these categories by multiplying the original numbers for this factor. Okay. Okay, so this builds the scenario, and all right. So let's check out this revision and see what happens with the test. So if I go here and run the test, and okay, so it seems to be failing because, okay, so let's check my current implementation. And again, so this fake implementation cannot pass the test because it's not really prepared to match all the scenarios that are being constructed via the data provider. Right, and that's exactly what is supposed to happen with a fake implementation. So it's probably time to build an actual implementation that can deal with as many cases as possible. By this point, we have a very nice and solid ground to go deeper into the specific details of every collaborator. So this is the point where we kind of put a hold on the maybe BDD approach, or the acceptance test, which was like testing the whole system, and we're going to go deeper into each and every one of the collaborators. So now we are switching to a more classic TDD. So we're going to be writing the test for the collaborators themselves, with the hope that once they are all done and all passing, then we can go back and see the whole thing working. All right, so we'll start with a very simple one, which is the price class. So let's have a look. So in this revision, we have the first implementation of the test for the price class. Let's check it out. So now here you can see that I have also created a separate hierarchy for the test. So I have this unit test, and this will be my acceptance test, the one that we've been looking at so far. So let's see what's with the price. Okay, so the price is a very simple class, and the only thing that is not allowed is for it to be negative. So this is what I'm doing exactly. Is I expect to get an exception if I create a price based on a negative value. And so this test could probably also be parameterized in order to avoid falling into the trap of the fake implementation, where either just the -1 number will raise the exception, or every number will raise the exception. But let's see just for this moment what's happening here. Okay, so I ran the test and it failed because it says that a negative price exception was not thrown. Okay, so let's see why that would happen. And it is because nothing is really happening with the price. So if we move a little forward, we check out the next revision, and now we see that the exception is being thrown every time, regardless of what the actual value is. So in this test, the test that I just ran, if I run it again, then it passes, of course, but then again, it is passing because of a failed implementation. So I need to do something to be able to prevent this from happening. Okay, so let's see what's the next step is to put together another test, another assertion, which is that it will allow non-negative numbers. And so here's a very interesting point that I wanted to make. Take a look at how this test is created. The first thing it says is this does not perform assertions. And that can be a little confusing because when we are creating a test, what sense can it make to explicitly say that the test will not perform any assertion? And the idea is that we are not performing any assertion directly, but what we are trying to determine is that the test runs, which means that creating a price based on a non-negative value will not create any error, will not raise any exception. And this explicitly saying that the test does not perform any assertions is a way for us to inform the testing framework that it's okay to not have any assertion performed in this particular test. If we didn't do this, the PHP unit would consider this an error, or at least a warning saying, hey, this test isn't doing anything. So let's run it. And of course it fails because, well, it raised this exception. So let's move forward in time. One more revision. And okay, now let's see what changed in the price class, and we see that the exception is thrown only when it receives a negative number. So let's rerun the test, or let's run them all. And okay, so we might say that this is done, and for this moment it is, and you probably are wondering, well, this seems to be okay, but we're not really doing anything with the value. And the thing is, probably at this particular point in the development of the solution, we don't need to do anything with the value. So I will simply leave that for when the time comes, when the need arises naturally. Then I will come back to this and create the test, or if should there be any, or the implementation of the functionality. This little workflow goes on for a few revisions. I will leave those to you if you want to check them out. I will jump directly to this revision because, well, there's not really much interest in all of the intermediate ones, but let's see what's happening here. So now here, if we compare it with the previous revision, we can see that I have introduced a new collaborator called Unusual Spending Calculator. And so the idea of the introduction of this collaborator is to better separate the responsibilities. So I am going into a refactoring phase here. And so the idea is to leave the trigger unusual spending email as a very thin layer of, like, you could think of it as a controller, and leaving all of the interaction with the actual repository to some other more specialized class. So let's see. So here we have this unusual spending function, which will actually simply forward the call to this new collaborator. So from this point on, you can go by the revisions, seeing how the code is evolving to the final solution, test after test, first failing, then fake implementation passing, and finally the real implementation. So here's the final version of the code, and let's see what we have here. Okay, so as you can see, it's a very simple class, the trigger unusual spending. Most of the logic behind it goes into the unusual spending calculator, which here I want to show you a little something I am using, which is here I am using a few of the very interesting functional programming features of PHP, which I also recommend that you do. And okay, so I think this is about it. A couple of comments I want to make before I wrap this up. In a more realistic scenario, I'd probably recommend implementing the class user ID the same way I implemented payment description. However, in the context of this kata, it would have probably made sense to stick to simple integers. And so, well, I already mentioned the functional features. Then it might have made sense to create a month class again to not directly deal with integers, which can have problems like they're not in the range of 1 through 12. And then one final note is in order to end up with a finished version of the code, I took a little shortcut, which was to relax the verification of the email format. In a more realistic scenario, I would probably have implemented a new class to render the email using the calculated values. But for the purpose of this exercise and this video, I wanted to keep things a little simpler, so I wasn't really making many assertions of the format of the email itself, but rather the contents of it. And I think that's it. So I hope you enjoyed this video. Don't forget to subscribe to get notifications about upcoming content. And as a next step, check out the code, study it, and leave any questions or comments you have right here. And I'll see you soon.